Hi friends, this is Naresh. In this class, I am going to explain about engineering drawing, and today's topic is construction of ellipse by using rectangle or oblong method and parallelogram method. These are the different methods to construct the conic sections. These six methods are used to construct ellipse, and these three methods are useful to construct parabola, and similarly these three methods are useful to construct hyperbola. Now in this class I will explain about these two methods, that is the rectangle or oblong method and parallelogram method to construct ellipse. Okay, before going to the subject, first of all you have to know the basic difference between circle, ellipse, parabola and hyperbola. Okay, ellipse, parabola, circle and hyperbola are called conic sections. Okay, because these curves appear on the surface of a cone when it is cut by some typical cutting planes. Okay, please read carefully. Conic sections appear on the surface of a cone. Okay, conic sections appear on the surface of a cone when it is cut by some typical cutting planes. Okay, so now I will explain some examples. So conic sections appear on the surface of a cone. Therefore, I consider a cone. So this is the cone. The horizontal line is called, this bottom horizontal line is called base of a cone, and these slant edges are called generators of the cone, and this sharp point, the top sharp point is called apex. Okay, and this vertical line is called axis of the cone. Okay, the angle between base of the cone and the axis of the cone is 90 degrees. Okay, now base, slant edges are called generators, vertical line called axis, and apex point, these are the terms used in cone. Okay, now I consider the cutting plane, that is a sectional plane. This is a sectional plane. If the cutting plane cuts all the generators, okay, if the cutting plane cuts all the generators and it doesn't cut the base of the cone, then the section is called ellipse. So this cutting portion is called ellipse. The ellipse will obtained when the cutting plane cuts all its generators of the cone. Okay, and the axis of the cone, and if the cutting plane is inclined to the axis of the cone and it cuts all the generators, then the surface obtained is called ellipse. Okay, in this case this cutting plane doesn't cut the base. Okay, it does not cut the base, only it cuts the generators. In case of parabola, here in case of parabola, the cutting plane is parallel to the one of its generator and it cuts the base. Okay, it cuts the base and one of its generator, then the surface is called parabola. Okay, this cutting portion is called parabola, this portion is called ellipse. Okay, the main difference between ellipse and parabola is cutting plane, position of cutting plane. Okay, in case of ellipse, the cutting plane cuts the generators only, but in case of parabola, the cutting plane cuts the base of the cone and one of its generator. Okay, and the cutting plane is parallel to the one of its generator. Okay, This is the main difference between ellipse and parabola. Similarly, in case of hyperbola, the cutting plane is parallel to the axis. Okay, here the cutting plane is parallel to the axis, or some angle, some small angle with the axis. Okay, and it also cuts the base of the cone and one of its generator. Then the section plane is called hyperbola. This is hyperbola. This section is called hyperbola. Okay, similarly, in case of circle, the section plane cuts all its generators, but the angle between section plane and axis of the cone is 90 degrees. Okay, here in this case, the angle between section plane and axis of the cone is 90 degrees. Okay, when the cutting plane cuts all its generators and parallel to the and perpendicular to the axis of the cone, then the section plane is called circle. Okay, now this is the common definition of ellipse, parabola and hyperbola. These are the loci of points moving in a plane such that the ratio of its distances from a fixed point and a fixed line always remains constant. The ratio is called eccentricity. Okay, here the fixed points are called focus points. Okay, here fixed points are called focus points and fixed line is called directrix. Okay, so eccentricity is the ratio. It is the ratio of the distance between focus and vertex. Okay, it is the ratio of the distance between focus and vertex to the distance between vertex and directrix is called eccentricity. Okay, if the eccentricity is less than 1, it is called ellipse. If the eccentricity is equal to 1, then it is called parabola. Similarly, if the eccentricity is greater than 1, then it is called hyperbola. Okay, now this is the another definition for ellipse. It is a locus of a point moving in a plane such that the sum of its distances from two fixed points always remains constant. Okay, in next slide I will give some examples for this definition. Now coming to the problem, draw ellipse by rectangle method. Okay, draw ellipse by rectangle method. Take major axis 100 mm and minor axis 70 mm. Okay, so this is the question. First question, draw ellipse by rectangle method. Take major axis 100 mm and minor axis 70 mm. And the another question is, a plot of cricket ground is in the shape of a rectangle. Okay, a plot of cricket ground is in the shape of rectangle having dimensions 100 meters into 70 meters. Inscribe an elliptical lawn in it. Take suitable scale. Okay, so in these two problems the answer is same, but the main difference is dimensions. Here in first question the dimensions are in mm, so you can easily draw on drawing sheet. But in case of second problem, the dimensions are in meters, 100 meters, 70 meters. Okay, we cannot draw on a drawing sheet. So in this case you have to consider a suitable scale. That means you have to consider a reduced scale. Okay, now I consider for this particular problem 1 meter equal to 1 mm. Okay, for this particular problem only I consider 1 meter is the original length. Okay, I consider 1 meter length as 1 mm on drawing size. Okay, on drawing sheet. Okay, so therefore 100 meters equal to 100 mm and 70 meters equal to 70 mm. Okay, now the question is in now the answer is same for both cases. Okay, these are the steps to construct the ellipse by using oblong method or rectangle method. Okay, first of all you have to know the dimensions of major axis and minor axis. The length of the major axis equal to 100 mm and the length of the minor axis is 70 mm. So first of all you have to draw a horizontal line AB. So the length of the AB line is equal to the length of the major axis. So the length of the major axis equal to 100 mm. So you have to take the length of the AB equal to 100 mm. So you have to draw 100 mm horizontal line. Now draw a vertical line CD. The length of the CD line is equal to the length of the minor axis, that is 70 mm. So length of the CD line equal to 70 mm, and these two are bisect to each other. Now in case of a rectangle or oblong method, you have to construct a rectangle. You have to draw a rectangle through these 4 points. So draw a rectangle taking major axis as major axis and minor axis as sides. Okay, so this horizontal line is equal to the major axis, that is 100 mm. This vertical line is equal to the length of the minor axis, that is 70 mm. Okay, in this rectangle draw both axes as perpendicular bisectors of each other. Okay, so for construction of ellipse, select this upper portion, this upper part of rectangle. Okay, here I consider this part as first. Now divide this vertical line from this point to this point. Divide this vertical line into some equal parts. I consider approximately 4 parts. Okay, so I divide this vertical line, that is 35 mm line, that is 70 by 2 equal to 35 mm. So 35 by 4. Okay, I divide this vertical line into 4 equal parts. So that 35 by 4, 35 by 4, 35 by 4, 35 by 4. Okay, 1, 2, 3, 4. Okay, I divided this vertical line into 4 parts. Okay, similarly you have to consider half of the major axis, that is from here to here. Okay, you have to divide same number of equal parts, that is 4 equal parts. That is from here to here the length is 50 mm, that is 50 by 4, 50 by 4, 50 by 4, 50 by 4. Okay, now join all these vertical points. Okay, now join all these vertical points 1, 2, 3, 4 to the upper end of the minor axis. So you have to join these vertical points to this point, 1 to D, 2 to D, 3 to D, 4 to D. Now similarly you have to join horizontal points to the lower part of the main axis, that is C2, C1, C2, C3, C4. Now these are the intersecting points, that is C1 and 1D. The intersecting point is this point, okay, this point. Similarly, the intersecting point of C2 line and D2 line is this point, and the intersecting point of C3 line and D3 line is this point. Okay, now D is the point of intersecting point of CD line and D4 line. Okay, C4 line and D4 line. Now join all these points to complete the quarter portion of the ellipse. So this is the quarter portion of the ellipse, and now repeat same procedure for this rectangle. Okay, repeat same procedure. Divide this vertical line into 4 equal parts and divide this horizontal line into same number of equal parts, and draw inclined lines. Same, repeat same procedure. Okay, C1, 1, C2, C3 and C4. Okay, and these are the corresponding intersecting points. Now we completed the half portion of the ellipse. Okay, now the given ellipse is symmetric about major axis and minor axis. That means the shape of the ellipse is same for remaining portion of the ellipse, remaining portion of the rectangle. So you have to repeat same procedure for bottom rectangles. Okay, this is the completed shape of the ellipse by using rectangle or oblong method. Okay, so this thick line, is final shape of the ellipse. Okay, now coming to the another model, that is parallelogram method, and the question is draw ellipse by parallelogram method. Draw a parallelogram of 100 mm and 70 mm. Okay, so draw ellipse by parallelogram method, and draw a parallelogram of 100 mm and 70 mm long sides. So the length of the sides is 100 mm and 70 mm with included angle of 75 degrees. Inscribe ellipse in it. Okay, the angle of inclination is 75 degrees. Okay, this is the question, and the another question is construct an ellipse when a pair of conjugated diameters are equal to the 100 mm and 70 mm. The angle between the conjugated diameters is 75 mm. The question is same and answer is also same. Okay, this parallelogram method is same as oblong method. The steps are similar to the previous case, that is the rectangle method. Only the main difference is here the vertical lines are inclined to 75 degrees angle. First of all, you have to construct a parallelogram. That means first you have to draw a horizontal line. This horizontal line, that is equal to the 100 mm. Okay, the length of horizontal line is equal to 100 mm, and take a included angle, that is 75 degrees at this corner and at this corner. You have to consider anti-clockwise direction. Okay, you have to consider anti-clockwise direction for measuring the angles, that is from this direction. Okay, from bottom to top portion. So this is a 75 degrees angle, this is also 75 degrees angle, and draw a inclined line. Okay, this inclined line, the length is 70 mm. Okay, so the bottom length is 100 mm, this inclined line's length is 70 mm, and join these top corners by using horizontal line, and draw a horizontal line and draw a inclined line same at the midpoints. Okay, you have to consider midpoints of these vertical lines and these inclined lines and horizontal lines. These the AB line AB and CD. Okay, the line AB and CD are called conjugated diameters. Okay, these are not major and minor diameters. Okay, in parallelogram method, you have to consider these two lines as conjugated diameters, and repeat same procedure for this portion. Okay, now divide this vertical line into some equal parts, say 4 parts. Okay, 1 2 3 4, and divide this horizontal line into same number of equal parts, 1 2 3 4, and join these vertical points to the upper portion of the minor axis, and join these bottom lines to the lower portion of the minor axis point. The corresponding intersecting points, that is the intersecting point of C1 line and D1 line is this point. Okay, this point is the intersecting point of a C1 line and D1 line. Similarly, this point is the intersecting point of C2 line and D2 line, and this intersecting point is the intersecting point of C3 line and D3 line. Now this point D is the intersecting point of C4 line and D4 line. Okay, now repeat same procedure for another portion. Okay, divide this vertical line, this line into 4 equal parts, and divide this bottom line into same number of equal parts, and repeat same procedure. Now these are the intersecting points. Okay, these are the corresponding intersecting points. Join all these intersecting points through smooth curve. Okay, this is the quarter portion of the ellipse by using parallelogram method, and this is the half portion of the ellipse, and repeat same procedure for bottom parallelograms. Draw some mirror lines, symmetric lines, you will get the same shape. Okay, this is the complete view of the ellipse. Okay, this thick line is called ellipse. Okay,